Welcome into video 2. So for this video, I don't think it will be very long. We're just going to briefly go over everything that has to do with inequalities. And I'll try to segment out the video. So inequalities, the first thing we want to do is we want to be able to go from words, say words, right, to, let's say, math symbols. So we'll go through a few different examples. Right, just to remind us, over here we have some signs, and so we'll write up the signs, and then we're going to go through some examples so we can define each one as we go. All right, so we have maybe this one looks familiar. We'll write this one, same thing with a line underneath, the other way, and a line underneath. And of course we have the equal sign too, but we'll save that. Okay, so maybe some of us can already fill this out. So if you're good with inequalities, no need to watch. But let's do some words to symbols. All right, so we'll do A here, and we'll say, ooh, I don't think I'm supposed to. This is fine. We'll say x is less than 9. Right, so we're just taking some words, right, an expression, and we're going to transfer this over into a symbol. Right, and so really what we're looking at here is what is less than. And so the operator, right, that we're going to use here, depending on where we put x. Normally what we do is we're going to put x on the left-hand side. So we'll write it over here. We'll write it right below, that's fine. So we normally write x on the left-hand side, followed up by the less than sign. So you could think of it's facing away. Right, you could think of this as opening up to the greater number, right, which is 9. So x is less than 9. So we'll write this over here. This one is less than, oh, I used the wrong one, didn't I? We'll go down here. Less than. Thought I put them in the right order. That's fine. So x is less than 9. And this x is just a placeholder, right? You could pick whatever you want. You'll notice here in B, I'm going to say, well, let's do y instead, right? It doesn't matter which one you choose. Normally you would see x, but again, these are just placeholders, names, x, y, right? You could say Michael is less than, it's just a placeholder variable. Sorry for any Michaels out there. Y is greater than, let's do, y is greater than or equal to 12. Right, so it can be two options. It can either be greater than or it can be equal to 12. Right, so again, we normally write our variable on the left-hand side. Greater than, right, we're facing it towards what is greater than, right, in this case, the y is greater than. Up here, the x was less than, so it's facing towards the 9. And if we ever have this word equals, we're putting a line below, right? So we'll write over here, greater, and I'll just put a slash for the or. I'll put or equal to 12. And make sure to write down these examples because I'm going to use these same examples moving forward, right? And we'll do one more. So let's do C. Let's say Z is greater than -2. And less than, this is the and sign. This is just an and sign. Less than or equal And let me move out of the way. I'm realizing now, maybe I've been blocking. Less than or equal to 6. right, so I'll hide over here. All right, so notice there's two things going on. Z is greater than -2 and less than or equal to 6. So in the case where you have two different things, right, two different comparisons, we're going to drop Z right in the dead center. And since we know that it's greater than -2, and we can put this finally greater, you could guess that the dan is there as well. So greater than -2, but it's less than or equal to, so less than, but or equal to +6. All right, so less or equal. So again, we're just looking at keywords here. Here's another one, greater, right? Less than or equal is another key phrase. We'll put one under this too. Greater than or equal, and less than, right? So that takes care of all four of our different options, right? Less than gets this symbol here, right? Facing the other way towards the 9, which is supposed to be greater than the x, since x is less than 9. Y is greater than or equal to 12, so it's facing towards the y. The bar underneath is what we get extra for saying the equal part. And then finally, we have two comparisons. Z is greater than -2, right? So we drop Z right in the dead center. It's facing towards Z, so it's greater than -2, and less than or equal to 6. So it's facing towards the 6, and again, we have the bar underneath for the equals. All right, so quick section. Next, what we're going to do, so there'll be a quick pause, stretch it out. We're going to go from symbols, right? So keep these examples written down, and we're going to go to the number line, right? So that'll be what we do next. All right, see you shortly. Jumping back into it from our quick break, I'm going to write up the previous problems we just did, right? Now that we translated them from words to symbols, right? So this was our first one that we translated from words to symbols, was x is less than 9. We'll write out B here, which was x, or we said y, we used y. Normally you would use x, but I just want us to get used to using different variables here. Right, I don't want us to get uncomfortable if we see something other than an x. Right, so y is greater than 12. And we'll use a different color. Last one, right, we were between two values. Let's say we were -2, so we said z is greater than -2 and less than or equal to 6. I'll move out of the way. All right, so again, the reason is we have x, y, and z. Normally, again, you'll probably just see x in your homework, especially since we're dealing with this one-dimension number line. But just so we get comfortable with variables, I mean, I know that's something that might scare people, the different letters that we see. So again, they're just placeholders. You can call them whatever you want. If you wanted to label one of them rock is less than 9, it wouldn't matter, right? It's just holding a place. Okay. So let's go ahead and we'll jump from the mathematical expression in symbols to number lines, right? And there's only a few things that we need to know here. So let's go ahead, we'll draw our number lines, and I'm going to switch sides. So hopefully I'll stand right in between, so I'm not in between either. All right, so we have x is less than 9. So I mean, we could put a 0 just in the dead center so we know where 0 is. And that means 9 is somewhere over here. You can just put some arbitrary 9. I know Alex will make this line graph for you. The key thing that we're looking for here is what is happening. We have a less than sign. So the associated less than sign, let's write over here, we'll make a kind of a key. Right, less than, and I'm also going to put greater than. So both of these options. Don't ask why less got the capital letter. Both of these options, oh no, greater than, I've been doing too much trig. Okay, either of these options, right, the things showing here don't have the wording equal to associated with them. So if we just have less than or greater than, it gets an open circle. So we'll just put an open circle. All right, so open circle. So in this case, right, we have less than 9, so we're going to go to 9. We're going to put an open circle. It should give you the ability in Alex to do so. And we want everything that is less than 9. So which way do we want to travel? Do we want to go to the right? Well, to the right is 10, 11. That's everything greater than 9. I want everything less than 9, so my arrow should be pointed this way, right? I'm pointed back the other way. So again, key things here, there's only really two things. One, does this get an open circle, or the other, which we'll talk about in a second, is a closed circle. And which way is this line pointing? In this case, right, you can always try some points too. If I plug in a 10 here, I have 10 is less than 9. That's not true, so I don't want to draw it that way. If you plug in an 8, 8 is less than 9, that's a true statement. That's the way I want to draw my line. Okay, let's go for the next one. Y is greater than 12. So let's just put a 0 here. Maybe we'll say 12 is somewhere about here to give myself some space. Right, so here in this case, we have the line underneath, which means equal. So we're just going to say equals if line underneath, right, and we know this stands for the extra equals. Essentially, that's what we're saying here. Even though we only draw one line underneath, it's standing for the equals, right? We get a closed circle. Right, so in this case, y is greater than or equal to 12. We'll put the closed circle at 12. And then again, we can go either way, right? We need to check which way we want to go here. So if I plug in 11, I have 11 is greater than or equal to 12. That's not true. If I plug in 13, 13 is greater than or equal to 12. That is true. So that is the way that I want to travel. All right, so key things. If it just has a less than or greater than sign, or in other words, it does not have a bar underneath, it's an open circle. If it does have a line or the bar underneath, meaning for equals, right, we have this extra or equal to 12, then it gets a closed circle. So let's do one more. We have 2, right, to evaluate, so we'll put a 0 here. We have a -2, and all the way over here we have a +6. Okay, so again, we have z is greater than -2. So notice there's no bar, so it's an open circle. I'm going to put the circles up here so we can see them a little bit more. And we have z is less than or equal to 6. Notice I said equals, right? So we get the closed circle. And now for this one, right, you can kind of test, right? So what we should think of is we're going to want the space in between normally, maybe not always, but let's go ahead and see. If I pick, let's say, a number over here, -3. Well, is -3 greater than -2? No, so we don't want that in our set. That's gone. If we pick something, let's say 7, is z less than or equal, or is 7 less than or equal to 6? No. So we want to pick something in between, let's say 0. Is that a true statement? Yes, right? -2, 0 is greater than -2, but less than or equal to 6. So we want this space in between. Right, so those are all of our different options. Again, the main things to take away from open circle, less than or greater than. If it has a line underneath, that means it is getting a closed circle, right? That equal sign gets the closed circle. That's what allows us to be equal to 12. All right, so that is it as far as we went through words to symbols. Now we've gone from symbols to number line. I'm going to leave these examples here, and I'm just going to show one other type of notation that you'll run into. It's not a big jump, so essentially all I'm going to do is erase this middle part. I'll even, and probably erase that part. I'll leave these. We'll go through one different notation, which is called the set builder notation. We'll describe it a little bit, and that'll be it. So I'll see you shortly. Take a quick break. Okay, last part of the video. So we still, as I mentioned, have the 3 same examples we've been dealing with. there's two things, I lied, there's two things we want to add, and I'm going to write them here at the top. We want set builder notation. Let me move out of the way, so I'll just write set builder. And this will be something probably new for most of us. Maybe we've seen it before. So there's set builder notation, and there's also interval notation. Okay, so set builder notation, I mean, it might be new, but it's very straightforward on how to go from this to set builder. And so essentially what you're saying is you want x is less than 9, and you want to write that in terms of a set, right? So all you're going to do is we use these curly brackets here to denote a set, right? And so I'm going to specify in my set, and I'll put one over here too, right? So the curly brackets tell us this is going to be a set, right? In my set, I want all of the x's, right? So this is just the placeholder variable that we're seeing here, right? So again, this line, the curly braces mean it's a set. You'll see your variable. You'll see a bar here, right? So maybe you're wondering, what does the bar and how should we read it? So this bar is read as such that. So we want all the x's such that x is less than 9. And you could think of this as like the criteria the x's need to be a part of the set, right? This is the criteria that x must meet to be in this set. And so it makes, right, it's pretty logical just to grab this. This is the criteria. X is less than 9 is the criteria. Those are all the x's we want. So this is the way that we'll write it, right? So again, essentially all you're doing is you could think of you're using the same variable that you're already given. We're writing a bar that means such that, and then we're writing the criteria that is already given to us, right? And same thing here, right? So we'll just keep going. So curly braces, because we're dealing with a set for set builder notation, my variable is a y, such that, and the criteria is already given to me. Y is greater than or equal to 12. And lastly, right, same idea, nothing changing here, right? We have the curly braces for denoting a set. I want all the z's that meet the criteria such that they meet this criteria that they are between, right, these two values, right? One of them is less, or one of them is just the greater than, the other one's less than or equal to, right? So this is not a big jump going from one to the other. Maybe it's different because we haven't used the curly braces before to denote a set, but I promise you that's the only difference, right? In this bar here, we try to confuse people with math symbols. It just means such that, right? So x, we want all the x's such that x is less than 9. We want all the y's such that y is greater than or equal to 12. And we want all the z's such that z is greater than -2 and less than or equal to 6, right? So that's the first part. I'll take a breath here. We'll draw a little bit of a line. Right, and now we're just going to go to interval notation. Okay, so interval notation is where we have the brackets and the parentheses, right? So this is a bracket, I'll write it down here. A bracket, or we have parentheses, right? So curl, right, we either have the square brackets or we have the curved parenthesis. And it's very similar to what we've already done with the line graphs from the previous section, right? Meaning this bracket is going to do the same thing as denoting a closed circle, right? Meaning if we have an equal to sign, we're going to use a bracket, right? The same as when we were doing our number lines, we used a closed circle. And the parenthesis means open circle, right? So the same thing. If it's just greater than or less than with no equals or no bar underneath, right, we're going to use the parenthesis. But we'll go through this, right? So our very first one, it says x is less than 9, right? X is less than 9. Notice that there's no bar underneath. And what do we also know is 9 is our upper limit. So it's our biggest number that we have. Right, so 9 is the biggest number that we can possibly have here. And again, there's no line underneath, so I know I'm going to want a curly, not curly, I know we're going to want a curved parenthesis here. Now the question is, what is the other number, right? So for an interval, we need two numbers, right? What is the other number? Well, the other number, right, if x is less than 9, it just keeps going on and on and on forever. We're just going to go to negative infinity. That's a bad infinity sign. I'll leave it, and with infinities, positive or negative infinities, you always have the parenthesis, right? So infinities, negative or positive infinities, always have, right, the parenthesis, because it's not a value you can ever really reach. And we're going all the way to 9, but we're putting a parenthesis at 9 because we really can't get to 9. We can get arbitrarily close to 9, right? But we can't equal 9, right? Because we don't have the bar. If we had the bar, this would be a bracket, but there's no bar stating we can be equal to 9, right? So that is our first one. Okay, second one. Y is greater than or equal to 12. Notice that I specified the equals to, right? So that means I'm going to get a bracket. So it says y is greater than or equal to 12. So in this case, 12 is the smallest number, right? 12 is the smallest number that we can have. So that's where we start our interval. We can't have a number smaller than 12. You can check. Maybe you go, well, let's pick 11. 11 is not greater than or equal to 12. 12 is the smallest number we can be. And it gets a bracket because of the equal to, right? That bracket is for the equal to. We start at 12. And then maybe you're asking the same question as before, where do we go? What's our stopping point? Well, we don't stop, we just keep going, right? All the way to positive infinity. That's a little bit better than the previous. But again, what do we know about infinities? We can never really get to them. They always have the parenthesis associated, right? So I'll make the rest of these here. So I want to be careful. This would be like closed dot, closed dot. So these would be two closed dots. This would be two open dots, right? So notice we can mix match what's going on here. In this case, both of them have the open parentheses. That's fine. In this case, we mix match. We can equal 12, right? I specified we can equal 12, but we can never equal infinity. And last one here, right? We have z is between, right? We have -2. So -2 is our lower bound here. And notice again that there's no line, right? This has no line here. So because it has no line, we're never equal to -2, meaning we need a parenthesis. I'm going to draw, so this one goes with that. This one goes with that one. This one's going with this one down here. Right, so -2. And we can go all the way up to our upper bound, which is 6. But notice here I'm allowed to equal 6. Right, so since I can equal 6, I can put a bracket. Right, so again, to recap really closely on this last part, right, the parenthesis, right, this mark goes with the open circle, right? And remember, the open circle goes to when it has greater than or less than, but it does not have the equals. When it has the equals to, which is right here, we get a bracket, right? So the bracket goes along with whenever we're allowed to equal that value. If we don't equal that value, it gets a parenthesis. And then the last kind of trick here is infinities. Negative or positive infinities always get the parenthesis, always. So I think that is it for inequalities. Right, so I think we are good. If you're waiting on that polynomial video, it is the one that will come out tomorrow. So give me a second. I will record it tomorrow and it will be up. Other than that, ask questions on Halo. All right, see you guys.